Every single night, your roof radiates heat upward into outer space, where temperatures sit at minus 454 degrees Fahrenheit. That temperature gap between your roof and the void above it is so extreme that even a thin layer of water sitting on a flat metal roof can cool an entire house to 70 degrees without electricity. No compressor, no refrigerant, and no power bill. By the end of this video, you will know exactly how to turn your roof into a cooling machine powered by outer space, and why the cooling industry has spent decades making sure you never found out. Hi, I'm Greg, and welcome to Building Grounds. Subscribe and hit the bell for more uncovering building secrets they never taught you. The roof above your head is the most exposed surface on your entire home. It absorbs more solar radiation than every wall combined. In single-story and two-story buildings, the roof accounts for up to 50% of total heat gain during summer. But that same exposure gives it a second property almost nobody talks about. Your roof is also the most powerful radiator on the building. Every surface facing the sky emits heat upward through infrared radiation, and Earth's atmosphere has a gap. Between 8 and 13 micrometers, there is a transparency window where thermal radiation passes straight through into outer space. Your roof is already using this window tonight. It is sending heat into a void at roughly 3 Kelvin. The coldest heat sink in existence is directly above you right now. 3 factors determine how well your roof can use that window. Emissivity. A material with high emissivity in the 8 to 13 micrometer range radiates heat more efficiently. Bare aluminum has low emissivity, around 0.1. Painted metal or oxidized steel can reach 0.9 or higher. The surface material you choose determines how much cooling power you extract from the sky. Sky view. A surface facing open sky without obstruction from trees, buildings, or parapets has a high sky view factor. A flat roof in an open area has nearly a perfect view of the sky dome. The more sky your roof sees, the more heat it dumps into space. Humidity. Water vapor partially blocks the transparency window. In arid climates like Arizona, the window is wide open and radiative cooling is most powerful. In humid climates like Florida, the window narrows but does not close. Cooling still works but is reduced. Now consider water. Water holds more thermal energy per unit of volume than almost any common material. It is cheap and non-toxic. Place a shallow layer on a flat metal roof, and that water absorbs heat from the building during the day through the ceiling. At night, it radiates that stored heat through the atmospheric window into space. By morning, the water is cooled, the cycle resets. The night sky functions as an infinite cold reservoir, and the water is the messenger between your home and outer space. The ideal depth matters. Too shallow and the thermal mass cannot absorb a full day of heat gain. Too deep and the water takes too long to cool at night. Research has consistently shown 4 to 8 inches provides the optimal balance. At 6 inches, you get roughly 30 pounds per square foot and enough thermal mass for typical residential cooling loads. 2,400 years ago, in what is now central Iran, engineers constructed towering domed structures called yakhchal. The word translates to ice pit. At the city of Yazd, you can still walk inside chambers rising 60 feet high with walls 6 feet thick at the base, made from sand, clay, lime, goat hair, and egg whites that achieved insulation values exceeding modern fiberglass. Outside sat long, shallow pools shaded by tall walls during the day. On clear winter nights, workers filled these pools with water. The water radiated heat upward faster than the surrounding air could warm it back. Surface temperatures dropped below freezing even when air stayed above 0 degrees Celsius. By dawn, workers harvested sheets of ice and stored them inside the yakhchal, ice in the desert made from nothing but water and the coldness of outer space. In India, the same principle took its simplest form. A shallow ceramic tray of water was placed outdoors, with the bottom and sides insulated by hay. On a clear night, the water froze even when air temperatures hovered above freezing. The critical detail is the insulation on the sides and bottom. Without it, warm air conducts heat back into the water faster than radiation can remove it. With it, the radiative loss wins. Insulate everything except the surface facing the sky. In 1952, a chemist named Harold Hay traveled to India as a government advisor on building materials. In impoverished communities, he observed that traditional water-based cooling techniques outperformed everything the industrialized world had built. Hay returned to the United States with a blueprint: put water on the roof, control the exposure, let the sky do the rest. After years without funding, Hay finally got a full-scale home built in Atascadero, California, completed in 1973. The system was called Skytherm. Plastic water bags sat on a corrugated metal ceiling deck. Movable insulation panels slid over the bags during the day to block solar gain and opened at night to expose the water to the sky. In summer, the panels closed at sunrise, trapping cool water above the ceiling where it absorbed heat from the room all day. At sunset, they opened, and the water radiated its stored heat into space. In winter, the cycle reversed. Indoor temperatures held between 68 and 72 degrees, while outdoor temperatures swung between 32 and over 100 degrees. No auxiliary heating or cooling was used during the entire test. A Department of Energy report confirmed that well-designed roof ponds maintain comfortable temperatures across outdoor ranges from 32 to 115 degrees Fahrenheit. The metal ceiling deck is not optional. It is the thermal bridge between the water above and the living space below. Hay used corrugated steel because it conducts heat rapidly and provides structural support for the water load. The corrugation increases surface area, which improves heat transfer in both directions. A flat drywall ceiling with wooden joists would insulate the room from the water and destroy the entire effect. The ceiling must be thermally conductive, steel or aluminum deck with minimal insulation between the metal and the interior space. In 1974, Hay testified before the United States Congress. 2 years later, his Skytherm house was recognized by the American Revolution Bicentennial Commission as one of the 200 most promising inventions in the country. 5,000 years of civilization had already proven the concept, and then the building industry buried it. In 1902, Willis Carrier invented mechanical air conditioning. By the 1920s, the Carrier Corporation launched campaigns positioning compressor-based cooling as the symbol of modernity. Their marketing explicitly framed passive cooling as primitive and unsanitary. By 1945, the post-war building boom standardized mechanical cooling as the only acceptable approach. ASHRAE codified it as the baseline for all thermal comfort calculations. By 1980, fewer than 3% of American architecture programs taught passive cooling. Contractors today have never heard of roof ponds because their licensing exams never mention them. An entire field of proven engineering vanished not through failure, but through deliberate exclusion from professional memory. The International Residential Code requires roofs to prevent water accumulation. Ponding water is classified as a defect. There is no compliance pathway for intentional thermal mass water storage on a residential roof. A technology proven since 1973 has no legal way to pass inspection in most jurisdictions. A 6-inch roof pond adds 30 pounds per square foot. Standard residential framing is not designed for this, and the code provides no template for approval. Follow the money. The Air Conditioning, Heating, and Refrigeration Institute spent over $47 million on political activities in 2022 alone. In 2019, an ASHRAE technical committee rejected a proposal to create a performance pathway for passive cooling. The stated reason was insufficient domestic data while ignoring 3 decades of European documentation. 67% of that committee represented HVAC manufacturers. Every roof pond installed is an air conditioning unit never sold, a compressor never replaced, a service contract never signed. The $29 billion residential cooling market cannot survive a technology that costs nothing and runs on 0 watts. But the physics never stopped working, and modern science has given you tools Harold Hay never imagined. In 2014, researchers Shanhui Fan and Aman Rahman at Stanford published a paper in Nature describing a multi-layer photonic structure that reflects 97% of sunlight while emitting heat through the atmospheric window. Their panels achieved cooling of 5 degrees Celsius below ambient under direct sunshine. Not at night, at noon. What Hay could only achieve after dark, Stanford achieved in broad daylight. They founded SkyCool Systems. Their panels have been tested across California, Florida, Indiana, Kansas, Nevada, and Texas, reducing energy consumption by 15 to 20%. A California Energy Commission report confirmed the system increased heat rejection by 34%. These panels bolt onto existing HVAC systems and pre-cool the condenser loop, meaning you can integrate radiative cooling into a conventional system today. At the Florida Solar Energy Center, researcher Danny Parker built a system called NightCool. A standing seam metal roof with high infrared emissivity sits over a sealed attic space. Inside the attic sits a concrete slab or phase change material that stores coolness. During the day, the attic is sealed from outdoor air. The thermal mass absorbs heat from the living space through the ceiling. At night, a fan opens the attic to the metal roof surface. The roof radiates heat to the sky and the thermal mass recools. The system achieved a coefficient of performance near 11. Your backyard air conditioner achieves 2.5 to 3.5. This was tested in Central Florida, one of the most humid climates in the country. Parker's design eliminates the water bags entirely and sidesteps the structural weight concerns that block traditional roof ponds from code approval. If you are building a new home or replacing a roof, this is the most accessible approach right now. A metal roof is already code compliant. An insulated sealed attic is standard construction. Adding thermal mass and a controlled ventilation fan is within reach of any competent builder. At the University of Colorado Boulder, engineers described a glass polymer metamaterial achieving 93 watts per square meter of cooling at noon. The breakthrough was roll-to-roll manufacturing, affordable material produced like plastic wrap and applied to any existing roof. This could turn any standing seam metal roof into a radiative cooling surface without adding water weight or requiring movable insulation. A central air conditioning system for a typical American home costs between $3,000 and $7,000 to install. It lasts 15 to 20 years. It consumes roughly 2,000 kilowatt hours per year, adding roughly $300 annually to your power bill. Over 20 years, you spend between $9,000 and $13,000 on equipment and electricity for cooling alone. That does not include maintenance or emergency repairs. A properly designed metal roof with a sealed attic and thermal mass costs more up front, but the operating cost is nearly zero. Parker's NightCool system used a circulation fan drawing under 200 watts. Over 20 years, that fan costs a fraction of what a compressor consumes. The economics are not close once you account for the full life cycle. The International Residential Code still classifies standing water on a roof as a failure condition. The Energy Conservation Code provides zero credit for passive radiative cooling. Parker's NightCool sidesteps the water weight issue. SkyCool's panels integrate with existing systems, requiring no code variance. Colorado's metamaterial film adds no structural load at all. The path forward is not to fight the code, but to use science that has evolved beyond the code's ability to block it. Harold Hay spent his final decades giving away his fortune to fund this research. He donated $500,000 to the University of Nevada, Las Vegas, and $50,000 to Ball State University. At 98 years old, he was making what he knew would be his final push. Modern researchers at Stanford, Florida, and Colorado have refined his vision into forms you can actually build today. Your roof is radiating heat into space right now. It did so last night, and it will do so tomorrow night. The only difference between your roof and a radiative cooling system is intention. A metal roof selected for high emissivity in the atmospheric window, an insulated attic designed to channel cooling downward, a thermal mass layer to store and release coolness across the daily cycle. The Persians made these choices 2,400 years ago. Harold Hay made them in 1973. Shan Hui Fan made them in 2014. Now you understand the science well enough to make them yourself. The coldest heat sink in the universe is directly above your house every single night. The only question is whether you decide to use it. If this changed how you think about construction, please subscribe to Building Grounds with Greg. Then watch the next video appearing on your screen right now.